Here's a video about ratio problem solving. What I'm going to do in this video is go through the first 4 questions of the should task, which is ratio problem solving this week. So it's up to you how you do it. If you feel quite confident, then you might go ahead and do the should task and mark the answers and find you can do it and not need to watch this video. If you're struggling with that task, or maybe you're happy with most of the questions but you're just struggling with 1 or 2 of the questions, then you could skip through to the parts of the video of the ones you're struggling with. Obviously only with those first 4. If you're really struggling with another one, you need to let me know and I of course will help you out. Question 1 says, the table below shows information about the number of medals won by 6 countries in the 2016 Olympic Games. A. Write down the ratio of the total number of medals won by Italy to the total number of medals won by France. Well, I can see here that Italy to France, I should start with Italy, shouldn't I? Italy has won 28 medals and France has won 42 medals. So the first thing I'm going to do for 1A is have Italy to France is 28 to 42. However, the question does tell me to give my answer in its simplest form. Simplifying ratios is much like simplifying fractions. You can cancel down any common factor. I can look at both of those. I can see they've both got a common factor of 7. So I'm going to divide them both by 7 and make it 4 to 6. But much like cancelling common fractions, you need to make sure you keep doing it until they're in their simplest form. These two have still got a common factor of 2, so I can divide it by 2 to give me a ratio of 2 to 3. Question B says, write down the ratio of the total number of gold medals won to the total number of bronze medals won. Well, I'm going to get out my Casio calculator here. I can see that gold medals is going to be 7 plus 10 plus 17 plus 8 plus 12. 7 plus 10 plus 17 plus 8 plus 12 plus 8. 7, 10, 17, 8, 12, 8. Fantastic. Some of you will use your ninja skills to do that mentally, I'm sure. Gives me 62. Total number of bronze medals, 6 and 14, and 15 and 8, and 21 and 10, gives me 74. So it's going to be 62, 74. Again, I need to look for those common factors. The only one I can really see on this one has got a common factor of 2. So I'm going to divide by 2. Gives me 31 to 37. Moving on to question 2. There are between 30 and 40 sweets in a bag. Ben and Daisy shared the sweets in the ratio 4 to 5. There are no sweets remaining. How many sweets were in the bag to begin with? I think this is quite a mean one, this one, unless if you're not confident with the ratio, but I think it's a good question. With any of these, if I've got a ratio, the first thing to do is draw my table. It says they're sharing it in the ratio 4 to 5. So I'm going to draw that table. Ben, oh, that's horrible, sorry, and Daisy, let's cross that out. Ben and Daisy in the ratio 4 to 5. Okay, now the key with this is sweets have to be a whole number, okay? At least you can assume if Ben and Daisy are sharing sweets that they're probably not trying to cut them up. It's going to be a whole number of sweets. So for example, if each part was worth 2, I'd have 2, 2, 2, 2, 2, 2, 2, 2, 2, 8 here and 10 here would be 18. Now it says there are between 30 and 40 sweets in the bag, so it can't all be 2. Maybe it could be 3, 3, 3, 3, 3, and so on. 3 in all of them. That would give me 12 here and give me 15 here. So that'd be 27, still not between 30 and 40. If it was 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, that's going to give me 16 here and 20 here, which is 36. So I know that that works. I'm going to double check 5 though, because maybe 5 will work as well. 5 in each of these would be 20. 5 in each of these would be 25, which would be 45. So it doesn't work. So the only way they could share them in that ratio is if each part was worth 4. And that gives me 16 here for Ben. And Daisy, obviously, maybe a bit stronger than Ben or a bit intimidating or whatever, gets those extra sweets to get 20. That's question 2. Question 3. George buys some first class and second class stamps to put on letters. Someone should tell George to get email maybe. Each first class stamp costs 67p. Each second class stamp costs 58p. The ratio of first class stamps to second class stamps that he buys is 1 to 4. George bought 20 stamps. How much did they cost him? Well, this one is just a bit long. It's not, I think, as mean as the other ones. It's less difficult as the other ones, but it's quite long. There's a lot to it. So we need to do one bit at a time. Look at the information. Each first class stamp costs 67p. Well, that's great. We can't really do much with that on its own. Second class costs 58p. Again, that's great. We can't do much with that on its own. The ratio of first class to second class is 1 to 4. Well, we can do something with that. All right, question 3. And we can draw our table. First class to second class is a ratio 1 to 4. Fantastic. Let's go down. Still can't really do anything about that money. George bought 20 stamps. Ah, brilliant. Well, I can come back to my table. I know that all together there's 20 stamps. All together I've got 5 parts. So I need to share my 20 stamps between my 5 parts to give me 4 stamps in each part. If I was feeling a bit show off, I might try and draw 4 stamps in each one, but I'm not going to. That means I've got 4 first class stamps and 16 second class stamps. Now I can go back. Oh, now that 67p and that 58p is quite useful. I'm going to get me my friend the Casio back out. So it was 67p for a first class. So I'm going to do 4 times 67. I'm going to do it in pence. Some of you might be tempted to do it in pounds. I'm going to do it in pence. I'm going to write down the sum as I go. 4 times 67 plus... Now with BidMaths I can put a plus there. I don't need brackets. You could put brackets if you wanted, but I don't need them. 16 times, and those second class ones were 58. It's not much difference, is it? I might just get all first class ones for the sake of 9p. Plus 16 times 58. And that gives me a total of 1,196p or £11.96. Fantastic. I'm going to do one more together and then you're going to be on your own, I'm afraid, but obviously you can ask me if you're struggling. 1,935 people visit a library during 1 week. Yeah, if you say so. The ratio of children to adults is 1 to 4. No one visits libraries. Remember, they're all still shut, aren't they, I think? How many more adults than children visited the library? Quite a nice one, this one, really, I think. Draw your table. Keep drawing these tables. I've got children to adults is 1 to 4. I've got 1,935 all together. That's 5 parts being represented by that 1,935. So I'm going to share my 1,935 between my 5 parts, leaving me 387 in each part. Now, a couple of different ways you can answer the final question about how many more adults there were. What a lot of you might want to do, and this would be perfectly fine, is say how many children are there all together, how many adults are there all together, and subtract. So I'm just going to fill this in. And that would be fine, that would be absolutely fine. I think there's a slightly easier way to do it. Adults have got 4 parts, and children have got 1 part. So basically the adults have got 3 more parts. They've got 3 more 387s. So like I said, it'd be fine to just do all of these minus this. But actually I know that's just going to be 3 of these. These have got 3 of these more. So how many more is just going to be 3 times 387. I could use grid method, but I'm going to use my trusty Casio to tell me that's 1,161 adults more. Hopefully you found that useful. That's questions 1 to 4. That's the first half of the should task. If you have any problems with any of the tasks this week, do let me know.